Hello and welcome back. In this final installment of Lean Operations and Analytics discussion, I want to just, in a summarial sense, walk through quickly the 11 points that we have been repeatedly emphasizing, discussing, and bringing up all through our video sessions. And this is more serving as a summarial discussion, a lean video, just focusing on the conclusion. Okay, and for the details, you can always refer to the previous video series. Number one is improvements in subsystems must have impact on the whole processing. Improve based on overall improvement, based on the benefits enjoyed by the overall process gains, right? Don't improve a component, a particular resource in the process by itself. Maybe you think that the effective capacity has increased, but then you are improving on a non-bottleneck. So after spending all the upgrading and improvement works, the entire process capacity hasn't improved because the bottleneck capacity stays the same. Right now, yeah. So there's no point trying to keep improving non-bottleneck resources. So this statement here, right, this point here is in some sense re-emphasizing that the theory of constraints contribution, right? That look at bottleneck. Don't. But then, of course, this generalizes that. So in anything that you do, make sure that there is benefit to the overall gain by the processing line or the company, right? Or the product usage or the impact on the customer, right? So don't just improve for the sake of improvement. That's point number one. In order to stay lean, right? So lean means contributing value to the customer. Point number two, improve throughput, right? Keep your FR out as high as possible. Keep improving that. Align with the performance metrics to promote throughput. So keep improving your FR out. Maybe your FR out is artificially or unknowingly being suppressed. All right. So FR demand is high, but your FR out is always barely able to meet. So there is no worry about the sale of your products, but you always have a difficulty in trying to keep up with the demand. So it's kind of a good worry, right? So there's a lot of customers wanting a product, but it is not high enough for you to open up another production line because there's fixed costs, right? So there's no doubling of the demand, but there's high demand. So what you can do is you need to improve the throughput using various lean ideas, right? You reduce waste, use area of constraints, use total uh, uh, quality management, look through everything. Number three, focus on customer needs. So total quality management, TQM, right, taught us customer is at the center. Listen to customer. And value stream mapping says you need to start looking at what delivers value to the customer, right? And then work upstream. And then you can identify the waste and remove the waste. So operation strategy should enhance flexibility to cope with changing customer preferences. Customer preferences in its simplicity could mean fluctuations in demand. I want more, sorry, I want less. And how are you going to cope with it? You cannot say, why can't you make up your mind, right? If you say that, then bye bye, I go to another supplier. I didn't mean it, it's not my fault, right? So customers will say. But so how do you cope in such a way that you don't incur high costs? I say high costs because whenever there's change, then physically there's always cost that is involved. The only thing is don't let it go out of hand, right? Because when production side cannot have very low costs when they adapt to changes, it will translate into a very worried manager, very anxious sales manager, very tense customer service manager. That means they will translate that high cost into tension, into finally customer dissatisfaction. But then on the other hand, if you have very low cost, you can change a lot. You can also incur last minute change. Our company can always deal with it. Can always doesn't mean no cost. It just means so little cost on us that it doesn't matter. It won't affect our bonus. So you can imagine it will propagate down the line, because then the customer service manager will be told or briefed that, whenever customer wants to change, let them, right? Let them do it. It's okay. Because back end, the general manager knows the cost is under control. No issue. Yeah. So all these are very in sync. And on the production side, on the operation side, it has to be able to keep that flexibility. Point number 4, minimal components to form maximum product variety. This is always the magic formula for businesses or productions who try to win but who compete based on variety. Buy me because I have many choices for you. So if you go to any of those dessert store, you will know that they have 50 different products, right? So in the hawker center, with a barely just 2-meter wide storefront, they can sell 50 different products, right? So from ice longan, ice soursop, cheng tng, momo cha cha, and everything, all of them with very, very colorful mix. 50 different products. How do they do it? Do they prepare in the morning 20 bowls of ice kacang, 20 bowls of cheng tng, 20 bowls of this and that? No, right? You don't see that. What do? They have all the raw ingredients, the individual ingredients. The longans will be in one tub, the jellies will be in another tub, and then they have the syrup here, syrup there. Yeah. So okay, what do you want? I want ice longan. Good. Then you start grinding the ice. That's one component, produced on the spot, right? And then they put in some longan. Finish. That's the ice longan, right? Ice and longan with a bit of syrup. And of course, they will do the same, right? They just mix to order. Whenever you make the order, they will produce to your order. And they will have minimal components, right? Because the longan can serve as ice longan, can also serve as ice longan and soursop, can also serve as ice kacang with longan. Can also, so it's a component for like 4 or 5 different N variety products. So that's the idea. Right? Form postponement, same thing. Yeah, we talked about the HP power supply issue. When the power supply is built into the printer itself, 120 volts, 240 volts, European and US cannot interchange. So due to a very minor, the power transformer is a minor component of the whole expensive printer. But due to the minor component differences, the whole product cannot be redistributed to another locality. But then if they practice form postponement, then component parts, they are separated, they are not packaged until the final quantity demand is ascertained. Number 5, buffer demand variation with capacity, but not inventory. So try to have a high capacity machine that can produce a lot, if you need a lot. And of course, a high capacity machine can also produce little if you don't need a lot, right? Rather than make a lot slowly. That means low capacity but high inventory. You make a lot, keep making. Even at night you're making, in case there's a high demand tomorrow. You see the difference, right? So in the capacity case, we worry about tomorrow's demand. Yeah, tomorrow's demand can be high or low. So what we have is not inventory. We don't produce any. But if tomorrow demand is little, our high capacity machine can, of course, produce very little. If tomorrow demand is high, our high capacity machine can produce quickly high quantities. So no issue when we don't have to inventorize. Now what happens if not? If not, we have a low capacity machine. So what happens is we worry tomorrow demand can be high, can be low. So if it's low, our low capacity machine can match. But our worry is more in case the demand is double or triple. Then what should we do? We better start producing overnight. Keep producing, and inventorize the end product. So you build up a whole inventory of output, your products, just in case the demand is high. It's not that you know demand is high, you worry that the demand is high. So in case the demand is high, you can handle. But then what if demand is low? You would have all the waste. And worse is if the inventory doesn't have long expiry time, right? So it cannot be stored till 2 days later, 3 days later. Then you'll be in trouble. So you see, it's the wisdom here, buffer demand fluctuation with capacity rather than inventory. Number 6, develop alliances with supply chain management partners rather than ignore the supply chain ecosystem. So as this is especially wisdom for the manufacturer, sometimes for the agents in between the supply chain, right, like distributor, they might be able to try to take care of their downstream but also sell them. Primarily, this role and this desire and the ability to make this happen lies with the manufacturer. Manufacturer should look at their supply chain, that means their downstream, as partners, someone to share their information with. For example, I'm planning to make 1 million units next year, so I tell you upfront so that this distributor retailers know about this, and they can start planning for necessary inventory space, budgeting, people to deal with. They need to hire, and that takes time. So they will be treated as partners. Manufacturer is feeling secure enough, confident enough to treat them as partners, to tell them this information, rather than fearing that if they know about this, they will come and exploit and negotiate with me to price down my products sold to them, right? So if you have this kind of more confrontational thinking for the manufacturer, then it's no good. And if you ignore them, you just think of your own profit for the manufacturer. You just think that so long as I can sell it off my hand, that's good enough. I don't care. And that's also no good. So don't do that. Right? And we talk a lot about why this is not a good thing, right? So the conclusion is, look at them as partners. Of course, as partners, you want win-win, not win-lose, not a zero-sum game. You want them to be profitable so that they continue to be your partners for as long as possible. And of course, as partners, they cannot keep receiving care from you. They also need to take care of you, right? So when they are confident that they are taken care of by the manufacturer, they know the manufacturer will not shortchange them, will not exploit them, will not threaten them. Better do this or else I don't sell you, right? The manufacturer can do that. But with reliable manufacturer as their partners, the downstream people, the wholesalers, the retailers, they will also take care of their manufacturer whenever, within their capacity, they can do that. For example, they might want to tell you the actual ground demand to help you to reduce the chance of being bullwhipped. Or maybe the wholesaler wants to play a sort of a strategy game, right? Wants to game the system, wants to game the manufacturer's product. But if the retailers tell the manufacturer the actual ground demand, if the retailers work with the manufacturer, using some sort of a BMI arrangement, then that will be a good building up of trust and giving the manufacturer the very juicy, real information that manufacturer can depend on. Right. Next, we have point 7. Use pull, right? That's of course a very central theme. Pull is better than push. Let me say again. Pull systems such as Kanban in inventory management is always better than push systems, such as the so-called classical way of performing inventory management, like continuous review, periodic review. Okay, so that is, of course, discussed in detail in the inventory videos. So just remember, pull is better than push. Number 8, Bottlenecks pace the flow. It's like a drum beat. Bottleneck is like a drum beat. Whenever it beats, boom, 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 everybody follows. So if you look at the dragon boat race, all the rowing occurs in synchronization with the drum beat. Boom, then all the rowers will pull, boom, boom. In between, they will push the row forward, and then boom, boom, right? So only when all the rowers row in sync, then the dragon boat will speed ahead. If all the rowers row at their own, rhythm, it's all out of sync. It's all randomized. It's all cancelled out. The left and right all cancel out. The dragon boat will just circle around and on the spot, and it won't move at all, right? Not to mention even race. So that's the problem. And so here the idea of dragon boat race is that the process should be driven by the rhythm of the bottleneck. Bottleneck, instead of being the weakest to be condemned, to be blamed, is the other way around. Should be respected, should be the central scheduler, right? Schedule the bottlenecks on the most profitable products, right? So should be the central scheduler. Should schedule non-bottleneck resources to support the bottlenecks. So bottlenecks sort of dictates the rhythm of the rest. The rest can do faster, quicker, better, fine, but they have to obey the rhythm of the bottleneck. Don't go faster than the bottleneck. No point. You're not doing anything useful because you just be generating waste. So again, the theory of constraints said this a lot. Right? Number 9, time lost at a bottleneck, no good, because it leads to loss of output for the whole supply chain. So already bottleneck is slow, and you have time loss. How to have time loss? You incur breaks, correct? Yeah, you have longer setup time. You have breaks. You have excessive maintenance. You didn't supply the raw material, so that bottleneck is forced to stop because it's starved. It doesn't have raw material, so what do you want me to do? I'm working on nothing, right? So you didn't pay enough attention to feed the bottleneck. So all these are time loss. That's always not good. Time saved, right? On the other hand, at a non-bottleneck, you try to improve and reduce setup time and breaks and whatnot. At a non-bottleneck, that's almost like back to point 1. You're not improving with the sight of the benefit of the whole process, right? Non-bottlenecks, they are already better than bottlenecks in terms of capacity. So when you improve the capacity some more, it will not help the overall process. Yeah, so don't do that, wasting the time and effort. Point number 10, don't try to balance the capacities. For example, John, the bread making factory, right, has molding, baking, and packaging. So 2, 1, and 6 breads per minute. Don't try to balance means don't try to up the bottleneck from 1 to 6, like balance them, right? They're all the same. I mean, that's the theoretical ideal that theory of constraints says. Aim for that, right? But if you between trying to synchronize the flows and trying to balance the capacities, you want to do the synchronization of flows. So of course, with a conveyor belt, that's what most factory lines will automatically be doing, synchronizing the flow. Yeah, this point 10 wisdom comes in more strongly if John, the bread making factory, doesn't have a conveyor belt. Because conveyor belt not only conveys, but it also conveys in a synchronized manner, right? Yeah. So the breads will just move from left to right. Whenever the baking machine gets a new bread, the molding machine also gets a new bread. So it's all synchronized. But without the conveyor belt, like human movement of a tray. So human movement, I mean, you need to have an alarm clock to be synchronizing everything, but usually they don't. So whenever it's convenient, the worker will do that. And usually it may be out of sync. When it's out of sync, what happens? Queues will build at somewhere. Yeah. So that says this point here, more important, trying to synchronize the flows so that the queues won't form or tend not to form. And even if it forms, it's a very tiny short and temporary queue, not going to be a long queue. Yeah, remember, if it's long, then flow time is long. Then according to Little's law, the work in progress will be larger, and overall you just have more money stuck in the process. Yeah, so that's the thing. And number 10, 11, don't look at task completion times, but focus on project completion time. Again, back to one, look at the overall picture. So focus on project completion time. If you make a particular non-bottleneck work very fast, so the task for that non-bottleneck is completed in a very short time. So that's the task completion time. I finished this task, yay! But then overall, your company cannot deliver the so-called project. The flow unit is not completed because it is stuck and spending a lot of time at the bottleneck. So again, focus on project completion time, the flow time for the flow unit. Don't just look at improving a non-bottleneck resource. Look at bottleneck, right? How you can improve it, shorten the processing time. Okay, so that's a quick 11-point summary on the wisdoms and ideas that we have been discussing. Hopefully you find this useful, either for your usage in real life and for your exam. Thank you, and see you in the next video. Bye.